You know, when we think about manufacturing today, it's not happening in just one single building. It's this massive, planet-spanning web of factories all trying to work in perfect sync. But trying to coordinate that global dance, well, that's one of the most complex scheduling puzzles you can possibly imagine. Today, we're diving into a fascinating new algorithm that might have just cracked the code.
So let's just jump right in. Picture this for a second. You are in charge of a massive global company. You've got thousands of orders coming in, dozens of factories scattered across different continents, and inside each factory, countless machines. Your one job is to figure out the absolute fastest way to get everything done. This isn't just some brain teaser. It's a daily reality with billions of dollars on the line. And a new research paper is proposing a really powerful new way to solve it.
Okay, first things first, let's get a handle on the problem itself. It isn't just complicated. It's what researchers call an NP-hard problem. And a simple way to think about that is like a jigsaw puzzle, but one where adding just a single extra piece makes it 100 times harder to solve. The more jobs and factories you add, the complexity it explodes.
Now, the official name for this beast is the Distributed Flexible Job Shop Scheduling Problem, or DFJSP for short. Let's break that down, because it actually tells you everything. Distributed means it's spread out over lots of factories. Flexible means that inside a factory, a single task could be done on a few different machines. And job shop scheduling, well, that's the classic puzzle of figuring out the perfect sequence for all the operations. It's really a puzzle within a puzzle within a puzzle.
And this is not some abstract academic exercise. This is the logistical backbone of how almost everything you own gets made. I mean, the parts in your phone, your car, even the clothes you're wearing, they were probably made and put together in different corners of the world. Solving this DFJSP thing efficiently means products get to you faster, we use our resources way better, and costs are kept down. It is a huge deal.
So how in the world do you even start to solve a puzzle this massive? Well, it all boils down to making 3 absolutely critical decisions for every single task, and you have to make them all at the same time.
First, you've got to pick the right factory. Where in the world does this job go? Then, once it's there, you have to pick the specific machine for each little step. And finally, you have to decide the exact order, the sequence of jobs on that one machine. And here's the kicker. Every one of these decisions messes with all the others. Sending a job to a factory in Vietnam might seem like a great idea until you realize its machines are totally backed up, which means maybe a factory in Mexico is better. But wait, that completely changes the schedule for every other job you just sent there.
So how do you even keep score? How do you know if you found a good solution? The goal is to get one number as low as possible, the makespan. The makespan is just the total time, from the second the very first operation starts anywhere in the world to the moment the absolute last one is finished. It's like your final time in a massive global race. A lower makespan is a better score, and the lower you get it, the more efficient your entire operation is.
Now, because this problem is so incredibly difficult, no single algorithm, no one silver bullet has been able to solve it perfectly. So a team of researchers from Liaocheng University had a brilliant idea. What if they combined the strengths of 3 totally different methods to create something new and a whole lot more powerful?
They call their creation GA-VNS-CP. Yeah, I know, it's a mouthful, but the best way to think about it is like a dream team of problem solvers. Each member of this team has a very special, very unique skill, and by working together, they can crack this puzzle in a way that none of them could ever do on their own.
First up on the team is the genetic algorithm, or GA. Let's call this one the Explorer. It's inspired by natural selection, and it is fantastic at quickly scanning the entire massive landscape of possible schedules. It doesn't find the perfect spot, but it's super fast at figuring out the promising areas, the general neighborhoods where the best solutions are probably hiding. Next, you've got the Variable Neighborhood Search, or VNS. This is the refiner. Once the GA Explorer finds a good area, the VNS gets to work. It takes a pretty good schedule and just starts making these small, smart adjustments, swapping 2 jobs here, moving 1 operation over there, constantly checking if it can find a slightly better way right nearby. It's a master at taking a good plan and making it great.
And finally, you bring in the closer, constraint programming, or CP. This is the perfectionist. CP is this incredibly powerful logic-based method that can find the absolute, mathematically optimal solution, but only for a very specific, well-defined problem. It's way too slow to search the whole world on its own, but once the Explorer and the Refiner have narrowed it down to one tiny, high-potential area, the perfectionist can come in and polish that solution until it is flawless.
So why this specific team? Well, this is the really clever part. Their skills perfectly cover each other's weaknesses. The GA Explorer is great at seeing the big picture, but is sloppy with the details. The VNS Refiner is amazing with details, but can get stuck in a bad neighborhood. So you put them together, and they find a really good solution really fast. But even they can miss the absolute best answer, and that's when the CP perfectionist comes in to take their nearly perfect plan and find the true optimal arrangement. It's a brilliant synergy.
So, how does this dream team actually execute the plan? It's not a chaotic free-for-all. It's a very clever, very structured two-stage strategy that makes the whole thing incredibly efficient.
In Stage 1, you unleash the GA and VNS together. The Explorer and the Refiner team up to figure out the big picture stuff, which jobs go to which factories and the rough overall order. They find a high-quality global plan, not necessarily perfect, but really, really good. Then, in Stage 2, they hand that plan over to the perfectionist. The CP algorithm then looks at each factory one by one and solves the local puzzle of which machine gets which job in what order to absolute mathematical perfection.
So, that's the strategy. It sounds amazing on paper, right? But the million-dollar question is, does this clever team-up actually work in the real world? Well, the researchers put it up against a set of famously difficult problems that have been stumping experts for years.
And the results were pretty remarkable. The new algorithm didn't just do well, it found brand new world record solutions for 6 of these classic benchmark problems. These are problems that some of the best minds in the field have been chipping away at for a long, long time.
Let's look at some of the actual scores. On one classic test, the algorithm took the record from 519 down to 515. On another, from 388 down to 387. Now, I know these might look like tiny little improvements, but you have to remember, in global manufacturing, every single second counts. Shaving even a fraction of a percent off the total production time for something like a car can mean millions, literally millions of dollars in savings over a year. That's the kind of impact we're talking about here.
And if we look at the average performance across a whole bunch of test cases, the story is just as clear. This chart shows something called the mean relative percent error. Basically, it's a measure of how far off the solution is from the best known answer. So a lower bar is better. And as you can see, compared to other recent state-of-the-art algorithms, the new GA-VNS-CP hybrid just consistently found better solutions.
So let's zoom out. What's the really big picture here? What does a breakthrough like this actually mean for the future of how we make things? Well, the researchers themselves summed it up perfectly in their conclusion. Their hybrid algorithm simply outperforms what came before it. By setting new world records on these super tough problems, they've given us a powerful new tool to optimize the incredibly complex world we live in.
But the real takeaway, the big idea here, isn't just about this one algorithm. It's about the dream team approach. It proves that by combining the broad, almost creative exploration of one method with the strict logical perfection of another, we can start to solve problems that are just way too big and way too complicated for any single approach to handle by itself.
And that's a powerful lesson that goes way beyond the factory floor. It really makes you wonder, as our world gets more and more complex, as our challenges in logistics, finance, even in scientific discovery get bigger, where else is this kind of hybrid intelligence, this beautiful combination of creative exploration and logical perfection, going to be the key that unlocks the next big breakthrough?